So we're on to the next section, 2013. This is a quick one, part D. Describe the structure of benzene in terms of the bonding between the carbon and hydrogen atoms. So this should be okay. Single bonds there contain sigma bonds. So part 1, what type of bonding? It's simple, you just say sigma bonds. So sigma bonds, and that is between carbon and hydrogen. Then part 2, it asks you the bonding between the carbon atoms. So in between the carbon atoms, where if it's a C single bond C, that's going to be sigma bond. However, it's a C double bond C, you're going to have a sigma bond and pi bond. And that gets you the marks for that. That's all that's needed, nothing more than that. So 2013 question 8. Let's have a look at this reaction diagram. It asks us to do lots of things in here, but normally what I do is I go to these diagrams first of all and try to identify what's happening. So I'm going to start at the top, and I'm looking at C2H4 turning into C2H6. So obviously what's happening there is you're adding a hydrogen because you have 2 extra hydrogens on the C2H6. So this process, if you're adding hydrogen, is going to be called an addition reaction because you're adding it on. Let's have a look at the next one, C2H4 going down to this one here. Now sometimes it's a little bit harder to see. So what you would have to do here is maybe draw out the molecule on the side of the page. So to draw this molecule out here, you're going to have a look at CH2 and then the Cl. Now when you have the Cl followed by the CH2, it means these are bonded together, which basically means you're going to have a CH2 like that and a Cl on top. There's your CH2Cl. And then you're going to have another CH2 and a Cl bonded to each other, but they're bonded to the other part of the molecule. So this is also going to give us a CH2 and a Cl. So as you can see from this, this is 1,2-dichloroethane. So this is a chloroalkane. So we've got 1,2-dichloroethane. Up above here we have C2H4, that is ethene. And in here C2H6, again if you draw that out, that is ethane. Next we have down here, which is A. So A then is saying, well, what happens if you take away a HCl from this? Well, if you take away a HCl from this, you're left with 2 carbons, 3 hydrogens, and a chlorine. So if you knock a HCl off that other molecule, so what I'll do is I'll copy this molecule here. And we'll bring it down here. Now, if you're trying to take a HCl off this molecule, you're going to be left with some unpaired electrons. So if we take a H off here, let's see. So the H is gone and the Cl is gone. So now we have 2 unpaired electrons. So obviously it can't form this sort of bond. So what way can we arrange this? Even if you didn't know, you could probably try and work out the structure. The only way of doing it is by introducing a double bond. So you would have C double bond C. You could have hydrogen here, hydrogen here, hydrogen here, and a chlorine here. And that will give you the same amount of carbons. So taking a H and a Cl out, you end up with 2 carbons, which we have 1 chlorine and 3 hydrogens. So that would be the next one. And this is a chloroalkene. So this would be chloroethene. And then we have PVC. So that's polyvinyl chloride. And we'll come to that then in a while. That's polymerization. The only other one we're missing is the one that's here in the middle, which is a little bit harder to get at. So let's try and draw that as well. We've got CH3, CH2, and a Cl. So in this particular example, that is an ethane molecule, but it's got a chlorine on it, so it's chloroethane. So it's a haloalkane. So there's all the parts labeled. Once you have those, then it makes it a little bit easier maybe to answer the questions. So let's have a look at the questions. So 8a, ethane and ethene belong to a homologous series, alkanes and alkenes. Explain the underlying term. So a homologous series is straight out of question 6s as well. A homologous series is just any family of organic compounds that have a general formula, like CnH2n or CnH2n plus 2. And that's it. They have a general formula. There's nothing else needed for that. What type of reaction was involved in the conversion X? And we've actually described it already. We have an addition reaction. Also, not only for that, you can write an addition reaction will do, but you can also put in hydrogenation, because if you look at this, you're adding hydrogen, so that's hydrogenation. And also it's a reduction reaction as well. We've seen that anytime we're reducing, we always add H2. Now for me, I would just go with the addition reaction. It's the easiest one to remember, and any one of those will answer that. The next question then says, how does the geometry around the carbon atoms change as a result of conversion X? So if you're moving from ethene to ethane, how is the geometry changing? So let's have a look at that. Well, ethene is shaped like this, and we're going to add our hydrogen, and it converts into ethane. So when you're talking about ethene, ethene is a planar molecule. So what you end up having is 120 degrees of a bond angle. And this is planar. Now, what are you expected to come up with in this? You're just expected to come up with the word planar. And what does it change into? So when you go over here, the shape of this, which is ethane, is actually tetrahedral. Now what happens in the tetrahedral molecule? Well, again, you've seen the tetrahedral molecules before. Let's get rid of these bonds here. So in a tetrahedral molecule, you have two angles in the plane. You have one angle going out, and you have one angle then going in. So you end up with a bond angle of around 109.5 degrees. So that's a tetrahedral shape, and that's when it asks, how does the geometry change? It goes from planar to tetrahedral, and it's sufficient to just say it goes from planar to tetrahedral. You don't need the bond angles unless it specifically asks you for it. Okay, next question. Identify the reagent required to bring about conversion Y. So how do we get from ethane to chloroethane? So all of this is on the one page. Let's have a look. So conversion Y, that's what we're looking for, and there's conversion Y. How are we getting from C2H6 down to that? Well, it's only asking for the reagent. So the reagent for this is chlorine, Cl2. Because you've drawn them out and you can see you've gone from ethane to chloroethane. So the only way you can do that is by adding chlorine. The next one, which is conversion Z. So conversion Z is going to be going from ethene to chloroethane. So again, we'll have a quick look at that and draw it out. So we want to go from ethene to chloroethane. So ethene to chloroethane, and it's saying that this is Z and what's happening. Again, the only way you can go from ethene, which is that, to chloroethane, which would be that. Well, first of all, count up the hydrogens and see what the balance is. So we've got 4 hydrogens over here, and we have 5 hydrogens over here. So you're going to have to add a hydrogen, isn't that right? And then also you have no chlorines on the left, but you have a chlorine on the right. So that means you're adding HCl. And that's the answer. It's adding hydrogen chloride when it asks for the reagent. So just by looking at the molecules, you can figure it out. You don't even have to necessarily learn it. And then the final reagent was the conversion W. So conversion W is this one here. How do we get from ethene to what is 1,2-dichloroethane. So again, let's have a look at that. So we're going to go from ethene to 1,2-dichloroethane. And again, if you're looking at the structure of ethene and you want to get to 1,2-dichloroethane, well, the only thing that's happened here, we have the same amount of carbons, we have the same amount of hydrogens, so the only difference is there's an extra 2 chlorines. So therefore for this one, you're adding Cl2. And easy enough to work out. On to the next bit, describe the mechanism of W. So that is ethene plus chlorine, so it's the chlorination of ethene. Now at that point, I'm not going to go through the mechanism again, you've seen it already several times. You need to then just work out your mechanism in detail and just draw it on the page. D, draw the structure of A and give its name. Well, there it is there, we did that at the start. There's the structure of A and its name. And then finally E, draw the structure of 2 repeating units of PVC. So 2 repeating units of PVC. Let's have a look at that. So PVC stands for polyvinyl chloride. So polyvinyl chloride is made from chloroethene. So they're hydrogens and 1 chlorine. So this is chloroethene. And when you have the chloroethene, you just take another chloroethene. And what ends up happening is the double bonds break. And when the double bonds break, you end up with a situation where you have this. All these molecules joining together. So this is the first molecule. So this is hydrogen, hydrogen, hydrogen. This one here is chlorine. And then the next molecule, which is this one here, that is, again, hydrogen here, chlorine here, hydrogen here, and hydrogen. Now that's 2 repeating units. So this here is unit 1, and then it repeats again in unit 2, and that's what you're asked to draw. And that ends the end of that question. So hopefully that explains it a little bit more clearly.